And I'm live. Shit, I clicked on start streaming by mistake. But yep, cool. I'm live. And today is 17th of April, 2026, Friday. And yep, today's goal, or like this is stream's goal, is to understand. Yes, I was watching that. Is to understand this Terraform. And I found this pretty cool video, 27 minutes long. And yep, we will be watching this cool Terraform tutorial. Cool, we'll just watch this, do our stuff here in this folder. And what is Terraform? So, yep, Terraform is a tool that you use whenever you go to AWS. You have to create the server, choose the operating system, and install some softwares that you need. For example, if you are using Docker for deployment, then you need Docker installed. And if you need some other installations in that cloud machine, then yeah, there are some things that you need in that cloud machine. So either you do manually SSH into the machine when you are creating the machine and then install those things, or you can use something like Terraform. In Terraform, you can define what kind of what kind of operating system cloud you need, and connect your AWS account or Google Cloud account to Terraform, and then Terraform will just handle everything. Cool. Let's see how to use Terraform. And yep, hello, night stream. Yep, sure. Tomorrow we'll do like something. And yeah, I hope I do not get copyright. We will be watching this, and yeah, this is more like a reaction video. We are learning. Cool.
That took 32 seconds. Can you believe that? That would have taken me 15 minutes to go into AWS and click around and get all of that stuff built out. The VPC, the subnet, the route tables, internet gateway, security group, the EC2 instance. That would have taken me 15 minutes. And this is completely repeatable. What's up, everybody? It's Travis here from Travis.media. So I've been on this DevOps kick now for a couple of weeks. I figured I'd just keep the momentum going. And today we're going to talk about one of the more important tools in DevOps called Terraform. And before we actually get into it, let me tell you why you need to know it in 2023 or 2024, whatever year it is. I think that's the title of my video, so let me address that first. So if you're looking to get into DevOps or site reliability engineering or cloud computing, it's a...
And wait, 1 second. I messed up. Shit, I like actually messed up. Shit, I created a very cool thumbnail, but I didn't use it. Shit, wait. I started the stream beforehand. Shit. Yo, let's go. And if you are seeing the new thumbnail, like, please tell me. This one looks like actually pretty cool, much better. If you are seeing the new thumbnail, then like, please tell me. Sure, if you are still here. I can also check. Wait. I have to hide the home screen. That's so cool. New thumbnail. Let's go.
It's a requirement. It's literally on every single job posting out there. You might see CloudFormation, you might see Pulumi or something like that, but you're always going to see Terraform. So if you're in those camps, you're looking to get into those fields, then you must learn Terraform. And if you're a developer, you may not think this really applies to you. I mean, Terraform is for the DevOps, ops guys. I'm a developer, I don't need that. But to get ahead in this industry, you need to have a basic understanding of a lot. You need to know the gist of many things, and the more well-rounded you are in this way, the more you'll get ahead in the industry. So being aware of Terraform, how it's used, being able to use it in your discussions, maybe offer to utilize it or suggest it in your day-to-day work, I think is very, very important. Second, we all have side projects. All devs have some kind of side project they're working on. And whenever they start that side project, they have to spin up resources and get things set up. Why not use Terraform to configure all of that for you so that it's push button to get that set up? And then when you're done, push button to tear it back down. And last, infrastructure as code isn't going anywhere. In fact, it's basically the standard now. Nobody does the ClickOps stuff anymore. It's all code. The sooner you understand it, the better. And that's why I think you need to learn that this year, even if on a surface level. So in this video, I'm going to talk about it, tell you what it is, some of its benefits, and then we're going to do a practical dive into it. So whatever field you're in, if you're a developer, if you're a DevOps, if you're looking to get into any of that stuff, by the end of this video, you'll understand what it is and you'll be able to use it because I'm going to show you how. So first things first, what is infrastructure as code? Infrastructure as code is basically writing your infrastructure, which is your servers, your databases, your networks, all of that stuff, writing that to version-controlled scripts or code. It's your entire environment and infrastructure represented in a configuration code base. You can use one command, build the whole thing, every detail of it, and use another command to tear it all down. And since it's version controlled, teams of engineers can make changes to the code and update the infrastructure in one single source of truth. So in short, infrastructure as code is just what it says it is. It's your infrastructure represented and maintained by code. Second, what is Terraform then? Well, Terraform is an open source infrastructure as code tool created by HashiCorp. You can define cloud and on-premises environments in config files that are easy to read, they're version controlled, they can be automated and shared with one another. With Terraform, you can easily work with major cloud environments, AWS, Azure, and other tools like Kubernetes, Docker, Helm, etc. And you work with these services through third-party tools called providers. So there's a whole registry of these Terraform providers. There's the AWS provider, the Azure provider, Kubernetes provider, the Docker provider, a provider for each one of these services that allows you to interact with these services. And one of the best things about Terraform is it's agentless. You don't have to go installing agents on all your servers or databases or whatever. You just use these providers. These providers allow you to talk via an API to these services. So Terraform is an infrastructure as code tool. You essentially declare what your environment should look like, and Terraform will easily spin it up, update it, or tear it down for you. Now, before we get hands-on with this, let me give you some benefits of Terraform itself. Number one, it's multi-cloud. By using Terraform, you don't get locked into a cloud provider. If you're using CloudFormation, and you set up all these templates to define your AWS infrastructure, you're locked into AWS. CloudFormation is AWS only. You can't take that config file and then go to Azure and do anything with it. You have to go to Azure and use their tool and figure out how to deploy it all there. With Terraform, you're not locked in like that. You can build out AWS infrastructure, Azure infrastructure, GCP infrastructure, all in one place. You can deploy on all three with one configuration file. So it's multi-cloud. Two, it's stateful. It allows you to track your resource changes throughout your deployment in a state file, which is the single source of truth for your environment. Terraform uses this state file to determine the changes that you're making, to manage your infrastructure, to make sure that it matches with your configuration. So you make some changes to your configuration, it looks at the state file, sees the changes, and updates accordingly. So it's stateful. Number three, it's version controlled. All of your developers, engineers on a team can all work on this one code base. Nobody goes into AWS and starts clicking and building new servers in secret without anybody knowing, guessing at different parameters. It's all in one place, it's in public, and it's version controlled. People can pull down the latest changes and add to it, push it up, everybody else pulls down those changes, etc. Next, it's declarative. You declare the end state of what you want your infrastructure to be, and Terraform gets you there. You don't need to write out a bunch of steps like this happens first, then do this, then do this. You just declare what your entire infrastructure should look like and hand it over to Terraform, and it will create that for you. And then, like I said earlier, your team can just make changes to that configuration, like we want to change this tag, apply, and it'll go and change the tag. So that's number four, it's declarative. Number five, you don't have this manual ClickOps. Like your manager says, hey, we need 3 more servers. Travis, add 3 more servers. I got to go in and click launch instance, and then I got to decide a name, and then the instance type, and all this stuff. You don't have that. That wastes time. That, as I said earlier, is a secretive approach. Nobody really knows what you're doing, and nobody knows how to recreate that. Number six, you can save money with Terraform. I was on a project a couple of years ago where we had this development environment that everybody was working on, and it got pretty elaborate. Everybody was putting their stuff in there, and it just got expensive. And so we decided, hey, let's use Terraform to declare this environment that we have, and everybody leaves the office at like by 7 in the evening, and nobody really starts until 7 in the morning. How about from 7 p.m. to 7 a.m., we just destroy the whole thing. And then at 7 a.m., we build it back for everybody to work on, and if anybody needs to add anything, just add it to the configuration. And at 7 o'clock, we tear it down. So 12 hours a day, we didn't pay for the infrastructure. Number 7, it's great for disaster recovery. If you can spin up your entire environment in 5 minutes, it may not justify you having this instantly ready to go, this disaster recovery environment burning through money every day that you're not using. It may not make sense to keep it running all the time. And number 8, with Terraform, you can minimize user error. As humans, we make mistakes. We click the wrong things, we add the wrong VPCs and things like that. With Terraform, we can declare it and test it. And
nuts. Pretty cool. Yep. Hello. And yep, Terraform is like Nginx OS in that sense, that you can define your whole operating system and use it.
Deploy it and get it perfect. So those are 8 quick benefits to Terraform. I hope you see the importance of it now. So with all of that out the way, let's see how this works. So like always, go make you a cup of coffee. I have my tea, and we're going to learn how to use Terraform. So the first thing we need to do is install Terraform. If you just go to google.com and type in install Terraform, it'll bring you to this page. And you have a couple of options. You got your manual installation. I'm on Mac, so I just did a homebrew. So run brew tap to install the HashiCorp tap, and then install Terraform with this brew install command. Then of course, brew update and brew upgrade to make sure you have the latest version of HashiCorp. Once you have that, you can type in something like Terraform help to make sure that it works. And if you get this, you've installed Terraform. Next, jump into your code editor. I'm using VS Code. And create a new directory to do your work in. I have a directory called terraform-vid for Terraform video, and we're ready to begin. So the first thing I'm going to do is just create a new file called main.tf. That's
We will like follow this completely, and hopefully this is not like copyrighted. My video will not be taken down. Wait, I guess his voice is a bit higher. Eh, Cool. Nice. That was good. What happened to Gentoo? Gentoo, I was not able to install it on the virtual disk. So we had to run the code. I got the compiler in the live boot. And so, but yep. So everything was built. I think we had Grub. Grub was built. And also Clang, GCC were also built. So we had tools to do things. But then the Gen2 handbook website got moved. It was not opening, so I had no idea what to do after that. So we were not able to install it on the disk. We had to do the next steps from the live boot, and from the live boot, there is no CLI tool to submit to code forces. Code forces does not allow you to actually submit from the CLI. So what we did was we installed a Python project which allows you to pull questions from a specific context and test them out locally. So that is what we did in the end. No, just QEMU. QEMU is cool. I'm not using any wrapper around QEMU. And also Docker uses QEMU. I think I know. Yep, Docker's use of QEMU depends entirely on our operating system. And okay, QEMU is, I guess, one thing that Docker uses. It could use multiple things. And now already it's getting late. I would like to sleep, so let's continue.
Terraform. A TF file is a Terraform file. And the first thing we want to do in this file is declare a provider. Remember earlier we talked about providers? They are third-party tools we use to talk to different services. Like today we're going to use the AWS provider. That provider allows us to talk to AWS and interact with AWS. So my block would look something like this. And basically it just says provider is AWS, and it has a couple of parameters. So profile is default. I'll tell you about that in a minute. And the region I'm using is US East 1. So we declare the provider, and to actually authenticate with AWS, you need to have the AWS CLI. If you haven't downloaded that, just go to AWS, just type in AWS CLI, and right here, just install or updating. And this tells you how to install the AWS CLI. If I was on Mac OS, I would just download this package file. And once that's downloaded, you need to get a key and secret from AWS. So if I go to AWS and click on this drop down up here and go to security credentials, I can generate a new pair. And once that comes up, just scroll down to the section that says access keys and click on create access key and click on command line interface. And then click this box to confirm what you're doing and then click next. And you can set a description tag. I'm going to create this access key. So here's my key.
Okay, shit, we have to create a access key here. Okay, I migrated from Docker. Shit, there are different things. Admin versus Docker. Shit, next Docker is mostly used. Open source tools designed to build, run, and manage. While Docker is the industry standard, it is with a massive ecosystem. Podman is a security-focused alternative that integrates more natively with Linux and Kubernetes. Okay, that is cool. That is cool. But I guess using Docker is more beneficial in terms of most of the people use Docker. And if someone wants to run your project, they would be more likely would be using Docker and not Podman. Yes. Cool. So we have to go to AWS, AB South.
My key, what I want to do with that confirm, and once that comes up here and go to security credentials, I can generate a new pair. And once that comes up, just scroll down to the section that says access keys and
Security credentials. Yep, Docker is more scalable and the industry standard. I just use Podman for my personal projects. Okay, been using it for a year. Shit, you are a real human being. Shit. 2K4 F2H. And yes, you have been doing this for a year. It's cool. Access keys. Create access keys. Okay, okay. You do not see this when I click on show.
And click on Create Access Key and click on Command Line Interface.
It didn't ask me whether I want command line interface or what.
And then click this box to confirm what you're doing, and then click Next. And you can set a description tag. I'm not. I'm going to create this access key. So here's my key. What I want to do with my CLI is I want to make this a little bigger. I want to run, to configure it, I want to run AWS configure, and it's going to ask me for my access key. So I'm going to copy this access key.
Wait. Copy this.
Paste it here. And then I'm going to copy the secret key. And don't worry, I'm going to delete this before this video airs. If I don't, feel free to hack me.
That is not the access key. This is the access key. And the secret key. Okay, shit. Let me copy the secret key and I will hide my screen. I'm not really into coding like you. I learned Java and Spring just for some integration with the DevOps and backend. Hey, shit, you are a DevOps engineer. Yeah, that makes sense. Is your other name Andrew Bahadur? There is a person who comes from Nepal. He also knows a lot of DevOps things. And let me hide the screen. I'll be pasting some secret stuff. Default region name. Peace out. Okay, cool. Again, now show my screen. Okay, secret stuff is done. And back to following the man who knows.
And so I'm going to paste my secret key. Default region name, I'm going to keep it US East 1. Just if you don't have anything there, just put in your region. So US East 1. And then output format, I like JSON. So I'm going to choose JSON. And now if I go to cd.aws and then do a cat on credentials, I can see I have a default profile with an access key and a secret access key. This authenticates my CLI with AWS.
Okay, shit. .aws. There is no .aws. Okay, it is in the root. Credentials config. Yep, that does not have. Source is this, and output.
AWS. And Terraform can use that also to authenticate. So when you go back to the code and it says profile default, that uses my default profile. If I had something else here, like Travis, it wouldn't work. And then here's my region, US East 1. So that's my provider block. Now, whenever you create a new config or you pull down an already existing config that you're trying to use, you need to run a command called Terraform init. And make sure you save the file first. And what this is going to do, it's going to download your provider. So right here.
Okay. Stuff. Terraform. We have to create this file and shape. Terraform, and we have to say given the provider block. Okay. Provider is AWS and region is AP South, Asia Pacific South 1, and profile default. That is a random access key. That is not my access key. Profile default. and we are getting error right now because this is saying that provider does not exist because we have to do Terraform in it, I guess, like he is doing.
Trying to use, you need to run a command called Terraform init, and make sure you save the file first. And what this is going to do, it's going to download your provider. So right here, finding latest version of HashiCorp/AWS and installing that provider. So let's give that a minute to install that. Once that's installed, we can communicate with AWS. But remember, anytime you have a new configuration or you're using one that you pull down from somewhere, run Terraform init first. All right, and now if you have that option enabled, you'll see these hidden folders. Here's a Terraform folder with another folder of providers. If you go all the way through it, you see the AWS provider has been downloaded. And there's also a lock file. Next, we have what we call the resources block. So this declares an EC2 instance.
Resources. Okay. And also, I guess it's Andrew Bahadur. That is his name. It's like if you are here, I guess if you want to learn about Terraform, you should watch his video and not mine. Like get the knowledge firsthand. That will be cool. And, yeah. And then resource block, a provider block, resource block, where we are giving in AMI. What is AMI? Amazon machine image. Okay, shit. Amazon machine image. AMI is this. Debian AMI. I guess these different operating systems, Debian or Ubuntu, they have their own code like this. AMI code. Shit. Or maybe from UP. Yes, me from Meerut. We live in Meerut. Wait, and where are you from? Which why? In Terraform, we provide. Wait, I guess I can just copy this. Resource, AWS instance, app server, that is some random AMI 007868058A67C EC2 T2 not micro tags. Okay, you are from South. Hello. And wait, North India and South India are about to have a civil war. It seems like BJP government is pulling out a bill in which they are decreasing the percent share of South Indian states in delimitation bill. Shit, bro, we are going to fight. I don't know if I will be able to beat you or not physically. You might be going to gym every day. I don't know. We will have to see. Like, don't be too hard on me. Like, we are friends. Delimitation bill. But yeah, that is what they are doing is pretty bad. Shit, you left gym. Then I might be able to beat you. Actually. So net 4.6. Cool. And pretty cool. We provide in this. Okay. In Terraform, we provide this. Does each AMI that is Amazon's version of Ubuntu, Debian, Mac OS, Windows have a separate code which we provide here. Yes, exactly. Okay, that's good. That's good. And this is the unique format. Think of AMI, Amazon machine image, as a snapshot template that contains the OS plus pre-installed software. Every distinct image gets its own ID. OS distribution region, what varies? The AMI ID. Operating system, of course, operating. If you change the operating system, you will get a new AMI ID. And AWS region, the same Ubuntu 24 image has a different AMI ID in different regions. Okay, okay. This strips up a lot of Google. Yes, it should. This will only work in the region it belongs to. Okay, different regions in Amazon have their different AMI IDs. Okay, architecture. Yep, this would depend on architecture. Version Ubuntu. Okay, yep. Operating system version. Who published it? AWS, Amazon Linux, Canonical publish. Who published the AMI? How to find the right AMI? Yes, how do we find? Open the console, AMI ID catalog. Okay. It's out. EC2 dashboard. AMI. AMIs. Catalog, AMI catalog. Okay, okay, that is cool, that is cool. We would like to have Debian. Free tier eligible, okay, with x86 64. Select what did we select? Copy the ID for your region. Filter by OS. Yes, we did filter by OS. How do we? Oh shit! This is the AMI ID. Ooh. Shit. Okay, cool. And we have the correct AMI ID, which depends on the operating system, the region, and architecture, and a few other things. What else do we need? Instance type makes sense. What type of instance do we want? And then tags, which can have multiple things. Name is one of them. Let's go back to the video.
So the resource is AWS instance, and the name of it could be anything. I've called it app server. It has an AMI. I've put in this AMI ID, which is the Amazon Linux 2 server AMI. Instance type is a T2 micro, and I put a tag on it called my Terraform instance. Now, where do we get this AWS instance at? Well, if we go to the Terraform docs, so let's just do Terraform AWS. Click on this, and we should be able to see all of the options for an EC2 instance. So these are all the resources in an AWS provider. If we scroll down and find EC2, and then we see all the resources. We have an AMI, we have an EC2 host, EC2 tag, all of these things. But if we keep going down to AWS instance, this is what we want. It provides an EC2 instance resource. This allows instances to be created, updated, and deleted. So that's what we're using. If we go back to the code, we are creating an AWS instance. That's in the first quotes here. And the second quotes is the name of it, how we can reference it in our code, and I've just called that app server. It could be chicken wing, but app server is a little more appropriate. So we've declared an EC2 instance, we've declared the AMI, the instance type, and we've added a tag. How do we now deploy that to AWS? Well, all we do is type in Terraform, apply, and this is going to apply the changes to AWS. So let's hit enter.
That is pretty good. AWS, Terraform, AWS provider. We can go to this. Yep. And these are all the things we can do. Maybe we can even create a bucket. Shit, there is no bucket thing. Bucket. Okay, shit, Amazon buckets are called S3, so it might be by the name S3. S3, cool. S3 files, cool. Simple storage. And we are looking for EC2. EC2. Compute cloud. Image builder, EC2. Okay. AWS instance, AWS instance, AWS instance. Okay. And if you want to create here data, use this data. Wait. Shit, this isn't the data. AWS instance. This is also inside data. Resources. This is inside the resources. AWS instance. This is still says data. Okay, here we have the resource. Using AWS System Manager provides an AWS instance resource. This allows instance to be created, updated, and deleted. Okay. This is how we say example name AMI this and this. And this will just create an instance. That is pretty good. If we the instance name would be walrus, let's say. Walrus is very common. And name tag. This is a tag. And Terraform, apply.
And it would be helpful if I save this file first. So let's save it and try that again. And look what it does here. So let me open this up. It does kind of a git add subtract versioning here. It gives you a rundown of all of the actions it's about to perform. And if you see everything with the green plus, it's going to create that. So the AWS instance is going to create all of these things. So you see AMI, here's the AMI ID. If you see known after apply, this is because things usually don't get IDs and things like that until they're created. So this means we don't know yet. We'll only know after you apply it and run this command. So we can scroll down and see everything that's going to be applied. We have an EBS block device. We have some metadata options, a network interface, those kind of things. If this all looks good, which you should always check this over, if it looks good, then down here where it says enter a value, it says, do you want to perform these actions? We're going to say yes, and we're going to deploy this EC2 instance. All right, apply complete. So if we go to AWS now in the EC2 section of AWS, and you'll see that we have our instance, my Terraform.
Shit, that is like very cool. That is like actually pretty cool. You can create an AWS instance from command line. And these are the things, these are the options that we can change. AMI, we gave this AMI, Walrus 2. Hey, shit, it is saying that these are all the things that we could have given, and we gave this these things, tags, all tags. We want to do this. Yes, we do want to do this. Shit, creating a EC2 instance operation, run instance, HTTP response error is status code 400, request ID with AWS instance, this. We messed up. Filter. Shit. For a list of free tier instances, type describe instance type with filter this. Okay. Because I'm using free instance, so there are some changes. Credit. EC2 free tier. What is the code? Shit, they don't give any code. Right, free ensure uses free tier eligible instances types. Example, EC2 micro is a free tier eligible type. We can go to Amazon here and we can see instance types. So all of these are free tier eligible. We can use, okay, shit, T3 dot small is free tier. T3 dot small. And what do we get with T3? Either we are going to use T3 dot small or T3 dot micro. 2 CPUs in each, and architecture is also same. Memory, okay, wait, T3 here we get 2 GB memory with the small, and with micro we just get 1 GB. Let's use this one, T3 dot micro. Terraform, apply. Yes, we want to make this. This should work this time. I guess it is working. Terraform is talking to AWS, and also we have this uses AWS CLI. Let's go. This created an instance, and here we just define the type of EC2 instance that we want, the CPU and the name. We can also define more complex things. Pretty cool. Instances. Shit. Okay. Shit. Yeah. Oh, let's go. We have this. This is a tag. Okay. Shit. That comes here. What is Walrus 2 though? But anyways, that is pretty cool. Default. And how do we SSH into this? Can we SSH into this? Initializing status check is initializing. Here security monitoring. Security group is this. What are the key pairs? EC2 recommends setting this to require option. Keys. What is the key value pair used for this? AMI ID, Debian. Okay, I guess there is no way to SSH. EC2 instance. Here, these are all inside AWS instance. These are all the things that we could have given. Does anything say key name? Yes, let's go. Key name. We do have key name known after apply. Key name. We could have given key name. There is a key. Hello. Have you heard about NIRI? WM? Window manager. Nope. That is nothing. I'm not too much into Linux. I'm on Mac OS, unfortunately, so I cannot tinker and know these things. My bad. I can like pretend and run Linux in a virtual machine, but like, that is as far as I can go. Niri, cool. How does it look? Okay, well, he's excited. So must be good. DB Hyperland. Niri is generally considered easier to configure and more stable, whereas Hyperland excels in aesthetic customization. Okay, shit. I guess Niri is cool, In that case, it's like a infinite scrolling. Oh shit. Shit. That is very cool. Shit. That is actually pretty cool. Let's watch a video. Just getting some sidetrack. The WM video. Wait, why does it say that I have seen this video? Not gaming gameplay. I want to see how does it look like. Infinite scroll is crazy. On Windows 11, you can do this on Windows 11. Yeah. Niri rice. Shit, that makes sense. Yes, that actually makes sense. Copyright. I'm afraid. Shit, it actually is scrolling. It is scrolling like going left or right. Shit, that is cool. Infinite scroll. Everything just comes in this manner. Pretty cool. Pretty cool. And you can also do tiling. Shit. Shit, Pro got logged out. Shit, that is pretty good. Pretty good. But Hyperland is the best VLAN window manager. Yeah, I use Nginx because better battery life. Because this is simpler, so probably the internals are also simpler. Shit, this is actually good. Wait, what were we looking for? Key. How to provide key. Creating. Remember this. AWS instance. Yep. Argument reference region EMI key. Where was the key thing? Yeah, key name. Options key name, the key pair used instance, which can be managed using the AWS key pair resource. Okay. Public key. Okay, that is very good. That is actually pretty good. Given the public key here, key name. Okay, shit, that is pretty cool. So what we can do is I do have a default key for myself, and by default key I mean this dot ssh slash id rsa dot pub. This is my default public key, and just copy this and define it here. I think resource. Shit, this goes inside resource key pair. Okay, key pair is a resource. AWS key pair. AWS key pair, and name would be walrus. Public key is this. argument public key is required. We did. Key name is also Walrus. Argument public key is required, but no definition was found. Public key is being defined there. I guess bro is just hallucinating. PUBLIC. Okay. Oh shit. Cool. And here key name, we can just give a key name like this: AWS key pair dot walrus dot walrus. Okay, and Terraform apply attribute shit and team resource walrus dot walrus. This object has no argument, nested block. How do we provide the key like this? Keep here, key name, options, key name, the key pair to use for the instance. Yes. We just say walrus. There is no variable named walrus. AWS key pair dot walrus. Is that could be it. Terraform apply. Oh, that seems like to be, that is not. Inappropriate value for key pair is string required but have an object. Shit, so string is required. We can do that. Okay, battery life. When studying the exam for exams in Hyperline, I get about 4 hours, while with NIRI it gives 6 hours. Okay, you can study for 4 hours straight. That is crazy, but it is good for gaming laptop with 75% battery life. With Windows laptop, battery life is already messed up. NIRI, and NIRI also looks pretty good. At least unique. Infinite scrolling is pretty good. Terraform dot apply. Shit, there were some errors. No, shit, this is like we have removed these things and we have added these things. Cool, metadata is changing, lot of things are changing. Key name forces replacement. Let's go. Yes, we want this to happen. Creation completed after 1 second. Okay. If this works, we should be able to SSH into that server, which was created by this random thing. And also how to get IP address of AWS EC2 from Terraform. There should be a way to get this. Define output variables. Okay, output AWS public description. This value will be public IP address of EC2 instance. Okay, and this goes, where does this go? Terraform apply. This, I guess, output inside EC2. We are inside EC2. This is EC2. Argument reference. No, we do not need an argument. AWS instance dot example. Okay, which AWS instance we are talking about? This one, example, not is the public IP. Okay. This is like NixOS. Output, the name, name, AWS public IP, instance public IP. Is that a thing? Instance. This is some EC2 thing. So, yep, inside EC2. Actions, resources, these are the resources. We are looking for instance public IP. Instance public IP does not exist. What is instance underscore? Oh, that is different. I guess we given custom name here. No. Terraform, a name must start with a letter or underscore. Okay, cool. Argument value, the thing that we want to output. We want to output AWS instance dot walrus 2 dot public IP. There is no underscore, just public IP. Description is this is the public IP for the instance. Okay. Terraform apply. Wait, I don't really scroll. Detour at all. I just auto start my default tabs at a specific window. Pretty cool. You have defined workspaces, which apps should be in what workspaces. For me, number 1 is workspace 1 has the terminal, 2 is desktop, 3 is chat, if I can say chat, but yep, other people. If I want another terminal, I'll just use Nginx. Cool. Yep, Nginx is pretty cool. I'm planning to use NixOS. NixOS is pretty cool. You should use NixOS. And just need to be prepared when I am forced to use a non-Unix system. I mean, you are going to use it in WSL. So, non-Unix system. Shit, bro knows what I meant. Public IP. Like this, we can see AWS instance, specifically AWS instance here, public underscore IP, public IP. This is inside attribute reference. We can ID of the instance state, what is the state of the instance. We can output multiple things. Okay, public IP address, public DNS. Shit, let's also output this public DNS. Public IP and another output public. Shit, it knows, Podium knows where we are, what we are after. Okay. Yes, what are the changes? Just changes to output. We added a DNS and IP, which we do see right here. Cool. And this thing. And if our key went there, then we should be able to sh 13.201.1.96. This will use our default key, so we don't have to give I tag with the key. Okay. Okay, I guess, shit, I guess we have to say that we are opening port 22 for connection. I choose not use Windows, but it will always be my favorite. Hey, why not Windows 11, but Windows XP and Vista? Yes, Windows XP and Vista. Playing Taken 3 or GTA Vice City, like the best experience ever. Ports. How do we allow ports connection? Ports. Export. This is inside arguments. Ports. Import. No. Shit. How do we allow ports? AWS instance on this. Or maybe we do not. We define security group, and here we say that we want to use this security group. Yes. Security. AWS security group. Yep. We will define a security group. Example, name, provider. Okay, basic image with filters, group IDs if you want to give in multiple filters, argument. Okay, group IDs and region, name. Okay, how do we give in to security groups? Elastic Cloud Compute, list resources, AWS security groups. AWS, how do we configure us? Security group and then use it. Terraform and use it. AWS. This does not have shade. This does everything. AWS secure. What were we looking at here? We are also looking at AWS security group. Here also we are AWS security group. List resources. Resource. What is the difference? We are in here AWS security group inside VPC resources. Okay. So what are the things that we can give? Ports. How do we allow ports? These are the arguments. Ingress, regress, name, tags. Wait. 2 port required. End range port. From port. Start port or end range port. Is it included or not included? And these are required in protocol. Okay. These are some snippets. We can define AWS security group ingress. Allow TLS IV port. I have a Ubuntu VM Riced. Shit. Okay, that is crazy. Your Ubuntu looks like Windows XP. I use it to learn Linux commands with the basic interface of Windows XP. It's cool. And also now since you have Riced it, look like Windows XP, you must know how to rise a thing. Okay, resource, AWS security group, allow list, name, description, and then we are using resource security. Okay, we created a security group, and then we are changing rules for this group ID that we defined here. Allow TLS is the name. AWS security group dot allow TLS dot ID, get the ID, give the ID here, and VPC dot main dot ID, VPC virtual private dot ID. And okay, so we also have to define a VPC for a security group. But why do we have to define a VPC? Do you see anyway? Yes, a little bit. Why enemy list .NET? Yeah, bro, I have like a whole thing. I watched 141 anime, but it has been long since I added shit October 2020. Like that is not too long ago that I added an anime in this episodes. 5,000 episodes. This lockdown. Shit, you use AnyList. AnyList does not work now. They closed it, and they had a like very nice message. Or does it work? Shit. That must be some other website. But I do think AnyList closed. Or wait, I think it was AnyWatch. AnyWatch. Shit, AnyWatch there was a very cool website which worked. Yo, man. Okay, shit. There is an extension for this which syncs up. No, not AnyMixPlay. It was a very cool website. You could also do watch together thing with that. Okay, but like getting back to this, let's get back to this here. Here, why do we need AWS VPC ID define security group? Why do we need VPC ID to define a security group? Security group should be independent of VPC. But on that matter, what is a VPC? Security groups are not independent of VPC, they are scoped one. Okay, VPC I think might be region related thing. They are scoped. Here is why. A security group is essentially a stateful virtual firewall. Yes, that is what it is. That controls traffic to and from resources but allow port. This means nothing in isolation. Yep, we have to attach it to a security group. AWS's network is carved into isolated virtual private networks. A security group must belong to. It defines VPC. It is a logically isolated section of AWS's network that you fully control. You can think of it as your own private data center you hosted on AWS infrastructure. Inside a VPC, you define IP address, range, subnets. Okay, that is very cool. It is like you have a single Wi-Fi and you have multiple machines which are connected to the same Wi-Fi, and you are calling that a VPC. So if I create two instances in in the same VPC, and then only allow incoming request to them from local network, and only allow incoming requests, not to them both, to one from local network and to the other from global network. Then I can switch into the global one, and when inside the global instance, I can switch into the local one, in which is in the same VPC, but I won't be able to do this from my own personal computer, since that instance only allows requests from local network. Cool, shit. If that is the case, exactly right. Okay, shit. That Amazon, I was not familiar with your game. This is actually a deliberate, well-known pattern called okay, shit. This is a thing. Okay, not some random stuff I thought of. This is a thing. Well-known pattern called Bastion host. Bastion host. Our PC, we go into a instance. It allows requests from one thing, and then HCL. Let's go. They are using HCL ingress. Let's go. Okay, and we only allow SSH from within the VPC's range. Okay, from port to port on this port using protocol TCP. This means localhost, I guess, or local network. So when you SSH from inside the bastion, your traffic originates from this internal IP, which the private instance accepts. Your home IP is something like this, which that is very cool. This is similar to networks in Docker. Yes, very similar. Ooh, let's go. Okay. EC2 instance, container, VPC, Docker network, EC2 instance, a container, security group, ports, expose, and compose. Okay, public subnet is whatever we define, port mapping, private subnet. No ports exposed, just expose. Okay, and bastion host. Cool. A container, you exit into. Cool. So for what we are trying to do, we would like to make a VPC, AWS VPC, AWS VPC, like this, CIDR block. Okay, what is CIDR block? This is the basic usage with some tags. CIDR block option. This is option. The IPv4 CIDR is a thing. CIDR AWS VPC. used to define range of private IP address, classless inter-domain routing. Classless inter-domain routing. In AWS, in Amazon VPC, classless inter-domain routing notation is used to define the range of private IP addresses available for your virtual network. Can we not do this without a CID or classless interdomain region, classless interdomain routing? Okay, yes, explicitly said. Say, okay, something like this. Local area network. Okay, what does this mean? We are getting like a course in AWS here. Or explain this classless inter domain routing in AWS. This one. CIDR, it is a way to express a range of IPs in a compact notation. Okay, it is a notation like this: base and 16 prefix 7. How many bits are fixed? Okay, in this, the first 16 bits are fixed, and this okay, so the first, these two bits are fixed, and these two can be anything, the last two. In an IPv4 32-bit address, the 16 means the first 16 bits are fixed your network, and the remaining 16 are free. Fixed. And a single thing is 2 bytes, 250. To power 8. Shit, no, 2 power 8 is 2. When we say 16, that means this many are fixed, and these can be anything. So 32 into 16, yep. So when they are saying, yeah, this diagram is wrong, this diagram is wrong, this fixed should include these two also. 8 fixed bits. Okay, cool. A single IP address. Okay. Free bits 0 when we say 32. Cool. Cool. Okay. And the 10.0 at the start is the default, are the default first 16 bits in AWS local network. Are these default? I guess they are. No shit. Okay. Not a hard rule. This is one of the 3 private. Okay. We can have multiple private networks. Okay. Shit, this means within a single VPC also we could have different subnets. Okay, how much precision do we have here? Let's expel it off. Okay, there is AWS, which like has a lot of computers. in this AWS, we are defining some stuff called VPC, Virtual Private Cloud. This is like multiple devices who are connected to the same Wi-Fi inside the same network, you could say. And inside each VPC, we have EC2 instances. Yes, we can also write it inside EC2. Cool. Cool. We could have multiple VPCs in our AWS. And we could define them like this, and then we do have even more control than this. We can say in here we have 3 different choices for the subnet that can go with these. This and this. Good. And we can say this is brown, this and this. This is brown and this is brown. And we can say that these 3 begin with this ID, that these 3 begin with this ID, brown, and that these 2 begin with this ID, and these 2 begin with this ID, and they are connected. That is pretty cool. That is pretty cool. So we have AWS at the top, which is handling everything, and then we have these VPCs, which are like local area network, and within those local area network, we could have different subsets. That is pretty cool. Looks cool. We just have to confirm this. Inside AWS, can have multiple VPCs, which are like machines connected in the same network, and EC2 instances in the same VPC EC2 instance in the same VCP could have 3 possible subnets that they could be a part of, which are shared. Which are these. Close. Shit. Okay. We missed some point. Close, but a small correction. The 3 CID are not the subnets within a VPC. They are 3 different private IP ranges you could choose from when creating a VPC. Okay. Let me clarify. Okay, so we could not have more than 3 VPCs, or we could have multiple VPCs, but for a single VPC, we have to choose one thing, one of these CIDR block. Okay, VPCs are not really like machines on the same network. They are more like completely separate, isolated networks themselves. By default, they cannot talk to each other at all. You would need something like VPC peering to connect to them. Subnet within a VPC. When you pick, say this for your VPC, you then carve whatever subnet you want out of that range. Okay, okay. A single VPC has a single prefix for the subnet out of the three which are possible. Yes, okay, cool. So now what we want to define a VPC, give it a CIDR which is classless. What is the full form of CIDR? Classless inter-domain routing. Classless inter-domain routing. Okay, now we would like to create Terraform.ef. We have defined a key pair, AWS key pair, AWS instance, output. Let's define another resource, AWS. Okay, we have multiple that we could choose. What are we looking for? AWS VPC. AWS VPC. The name of this VPC will be walrus tags name walrus and CIDR block whose value is 100010/16. That is good enough, I guess. Something like this. Yep. We can define. Yes, cool. VPC with CIDR. Okay. We have a VPC. Do we have a VPC? Perform. Apply. Is it okay? This is like Nginx OS. Yep, cool. No errors at least. Create VPC walrus will be created. Okay, cool. Create a VPC with the given subnet. Now we would like to create a security group. Here, security group. Name, example, provider. Do we need a provider? Okay, we do need a provider. Filter. Wait, no, this is the bad one. Shape is possible like the bad one. Terraform, AWS, security group. This thing. Yep. Name, description, VPC ID. Provider stuff, keys. I guess keys can go at the bottom, and since this is a declarative language and not a procedural language, the order does not matter. Output. outputs. Resource, we should classify them. One would be VPCs and instances and security groups. Okay. Now we want to define a security group. Resource, AWS security group. Name would be SSH. What do we define? I guess we have provider is AWS. Tool name is SSH. Tool description and VPC ID. Provider. Okay, we are not given provider. Description is allows SSH connection from anywhere. Okay, and we have to give an VPC ID, which is equal to AWS dot okay VPC AWS underscore VPC dot Volvus dot ID. Okay, and how do we, when we are opening ports, we do something like this. Tags allow LTS. We can share, we can give this ingress thing inside port allow from 22 to 22, this from anywhere. This means like anywhere. Okay. Now we have to give this security group to this AWS instance. How to do that? AWS instance. Inside EC2, AWS instance, security group, security groups, optional. This is going to be a list of security groups. Security groups equals a list. That is how we define AWS security group dot sh dot name, just the name. Cool. Terraform apply. This is pretty cool. We are using CLI to create an AWS instance. We created a VPC, then, and this is version controlled, so that is pretty cool. We created a VPC in which VPC is like their way of defining a subnet. We created a VPC, then we created a security group. A security group is just a description for a firewall which defines which IP address do we want your connections to be in or out, or just firewall settings. And we have given that security group to our AWS instance. So now we should be able to SSH into it, because that is what we have defined in the security group. Okay, this is destroying the old instance, because I guess you cannot change, you can change the security group after the instance has been there. Shit. EC2 instance operation error run instance. The parameter for group ID is invalid. The value cannot be. Why is the value empty? I guess if SSH security group name is SSH, if we give here SSH directly, or if we just do not give this SSH, so that we first create the security group, and then in the next iteration we would use the same thing. I guess the problem here was the security group was not created. That is why we were not able to get its name. AWS instance, okay, what were the things that we did? Changes to output, said AWS instance created. Did we not create the security group? Yes, we did create the security group instance here. Security groups equal. Okay, this should work. No. What are the changes? SH instead of default, we are we do get the value. Now we are getting the value, and the value is SH. Okay. Last time we were not getting the value. Were we not getting the value? Here we got error because we were getting the value last time also. Okay, let's see. Cancel. Yes, do this. Instance is deleting. It is 12 o'clock. Shit. We are literally in the next day. Security group. Yep. If we give the name manual, Terraform.apply, or security groups, list of security group names to associate with, or if you are creating instance in a VPC. Wait, shit, we should. Is there a VPC? We want to create this instance inside a VPC. We give it VPC security group ID option, VPC only. Okay, that also does not work. We are giving now the ID instead of the name for the. Okay, now to add security group in AWS EC2 with Terraform. AWS security group A, like this: AWS security group, web server SG security group, name, description, VPC ID, replace with your VPC ID. We are using the correct VPC ID. Ingress, yep, define S egress output, I guess. Attach it to EC2 instance. Okay, resource, AWS instance, EMI instance type is this VPC Because this is like exactly what we did. Get the ID for the security group and add it there. Here we see security group ID. SSH is the name. Let's increase tags. SSH. I guess that might be the thing which was not there. Do they use tag? They do not use tag. 400 security group and subnet. This belong to different networks. And subnet security group with AWS instance. This on line 34 in the resource AWS instance walrus 234 resource. We create a VPC, AWS VPC walrus ID when we are defining the security group. This is what we give. Name for the security group. Maybe we should use something else. Substitute SSH with my SG. But yes, that should not be the problem. We are getting error here with MySG because this is not yet created. We just made the change here. Shit. Okay. I guess I see SSH substitute my SG with SSH. Terraform apply. That should work. That does not. Because that is not possible. Please. SSH. And yep, we cannot give this because this is like not the local network. If we do this, if we move forward with this, we will get error. Yeah. 10.0.0.0/16 bits. Terraform apply. Yes. Error. And the error is creating EC2 instance operation error. EC2. I'll go to the washroom and I will be right back in 1 minute. We will continue. We try to make sense out of this. Docker is running for some reason. Wait, not is your camera auto detect humans and change the position? No, it is not about the camera. It is this thing feature center stage. Now nothing changes, and now with center stage on, shit, it does follow me. Yeah, yeah, it does move. Center stage. It is like Apple thing. Good. So this is the error which run instances HTTPS response error. Security group this and subnet this belong to different network. Okay, seems like common error people were facing 8 years ago. 3 people to be exact. And this is also Terraform cloud formation template. Cloud formation template is a similar thing to Terraform, but just for AWS. Cloud formation is just for AWS, but with Terraform you can use anything, Google Cloud or whatever. When you went away, it turned yes. Wait, it was a ghost. If anyone using Terraform got here, yes, I had a okay. Shit here. The person who asked the question wasn't even using Terraform, but the answer came. If you are using Terraform, then do this. Shit, was unhinged. Shit. Continue. And this, or technically yesterday, shit, I had my final semester exam, last exam. Shit, final semester, you have completed your B.Tech. That is crazy. Now you are you are a grown adult. You would be expected by people around you and also your family to have a job, which I don't know. How is your job status? And cool, but you are watching some random guy from the north screaming at in midnight. Crazy. Okay, this create an AWS instance. Okay, why is bash running here? Security group ID. Allow HTTP. Allow HTTP is Amazon security group. Hunting. Yo, let's go. Hunter X Hunter. One. I am postponing my job hunting for a. Okay, you are postponing. So you I guess, are you going to do MTech, or I think there are a lot more industry things in companies in Tamil Nadu than in the north. Yes, but they are more about cars. I don't know. I don't know. There are a lot of car companies in Tamil Nadu industry. Like you have got it pretty good. Shit, these things are environment variables and not like this. Was the mistake here? These things are no. This is fine. This is wait. But if these are environment variables, then why were we getting values for these here? Here, bro. Okay, what is missing? I had a similar. Ended up happening was the following. The subnet I was deploying into didn't have a auto assign public IPs enabled. As such, I updated the AWS instance to include subnet ID. I guess they use these things as environment variables 8 years ago, but now we can use them as objects. Cool. Not complex stuff like that. I am moving to Japan for learning. Didn't get a job there. Okay, that is pretty good. That is pretty good. How does one do this? How do they go to Japan and find a job? Like, how much money does it take? Like, I would like to know. Are you in Discord? If you are in Discord, like, I would message you. I would say hello. I want to know how this is working. If I can do this, I would also like to do this. Go to Japan. That is like pretty cool. Okay. AWS instance subnet ID. Locals. VPC ID, subnet ID, local dot subnet ID. Give the AWS instance also needs a subnet ID, and the security group also needs a subnet ID. The VPS, who else is using the subnet ID? Shit, my bad. I mean, there is a difference between YouTube and Discord names, I guess. Or maybe I'm just too stupid. I didn't notice. My bad. Yes. Okay, I'll ping you. Cool. Sure. Operates everything about subnet ID variable is being used here. But where is it being filled? Okay, maybe I should not read Stack Overflow from 8 years ago. The error security group has a subnet, and the AWS instance also has a subnet. Here we are inside AWS instance. Subnet ID. Subnet ID. Does the VPS have a subnet ID? AWS security group have a subnet ID. It does not. Default subnet. Can we change the default? Given what I'm doing. Do we give the subnet to VPS? VPC. I think we give a subnet to VPC. No shit, we do not give a subnet to VPC. We give CIDR block. We don't have a subnet. that. Create a subnet with C. A subnet takes VPC I. Shit. A subnet takes VPC ID. We have to create a subnet. AWS subnet name would be walrus sub. Okay, walrus sub VPC ID. What does it take? Argument VPC ID is required. VPC ID. Wait, shit. Shouldn't this yep, VPC ID is the only thing that is needed. Subnet ID would be AWS subnet dot walrus sub dot ID. Okay, now it should work. Terraform, and we will end this stream when we are able to ping or SSH into the server, hopefully. Shit, okay, now the error is different. API error, the request must contain at least one of the following parameters. To subnet with this, okay, subnet must contain at least, when creating a subnet, what are the must contain things? CIDR block. Okay, let's give it a CIDR block. Perform here CIDR block would be 0, no, 10, 0, 0, 0, slash 16. Terraform apply. Okay, I guess it might work this time. Public DNS and public IP are empty. There is no public D. There is no public DNS or public IP. I guess that is because of the subnet. Something has to do with the subnet. Okay. When we give a subnet to a EC2 instance in AWS using, we don't have to be specific about what we are using to do this. Okay, when we are using Terraform to define a subnet, does that change the public IP, and does that public IP under which we want our EC2 instance to be? Because if that is the case, then the subnet that we defined here is not public. Therefore, our instance, if it is defined inside this subnet, would not have a public IP because the subnet is not public. No, shit, okay. The subnet does not directly define the public IP. It is a bit more nuanced than that. Here is what actually happens. Availability zone. This defines the availability zone. Okay. Which zone? Which private IP range, not the public IP range. Which VPC the thing lives in do not have a public IP somehow instances. We have like multiple sub instances. Wait, terminated. Okay, only two are running. We can turn this one off also. Yep. Terminate. Shutting down. Terminated. Okay. Refresh. Shutting down. This one availability zone. Okay, why does this not have a public IP address? Shit, we have to say this thing, we have to set this thing true in our AWS instance. Okay. Subnet ID, subnet dot public, and where is fix AZ plus private IP range. AWS EIP. Okay. Associate public IP address equals true, but we were not doing this before, and still we were getting public IP address. Terraform apply. Yep. Destroying the instance again. Creating a new instance, and raw, if we do see in the output a public IP, we do see a public IP address. SSH admin 43430.5.90.17. Still shit. We define the VPS in which we defined a security group which we are applying to this shit. Let's see. This is the current one which is running security in no security group. Okay, and how do we see all the security groups that we have? Elastic volume instances, network security groups. Are we even creating? Yes, we did create the SSH security group. Inbound rules, which allows from anywhere 2 to 2 range. Okay, but this security group is not applied to this instance. Why? Okay, it is applied. So anyone can SSH to this. Public IPv4. Okay, shit. So the why connection to this operation timeout SH AD admin 4. Can we change the username? Wait, let's go back here. EMI catalog. Here we choose Debian. And do we see the host name? Platform Debian. Root device EBS virtualization. Enabled, yes. And what does like this select button does? It just selects, okay, default user, admin, it is admin, default user is admin, sh into admin, USD 0.0598.127. Connection timeout. Okay, let's use some AI because I want to sleep. Here we have this, this creates an EC2 instance named walrus2 and allows it might be the protocol, it might be security group. Here we are defining this. Okay, no, we are saying that the protocol is SSH also. TCP, yes. SSH also uses TCP. Of course, it also uses TCP. And allows SSH connection. But maybe the SSH daemon is not running there. Yes, that must be the thing. Sure that D starts there. The SSH timeout is almost certainly not an okay shit. Subnet issue in your config. There is a issue in subnet CIDR conflicts with VPC CIDR. The subnet same as VPC should be something like, what, why no internet without an IGW traffic not flow between your instance and the internet at all, given a public IP address. If we do ping request timeout, but yes, it is able to see that this is a valid IP address. Fixing tags inside the VPC, keep this as it is. We have to make a internet gateway. Yet another term. We saw there are security groups, there are VPCs, there are subnets, and now we are seeing that there are internet gateways. Okay, walrus internet gateway, VPC ID, which also depends on VPC ID, internet gateway, subnet, map public IP on launch availability. Okay, a couple of things I do not understand. Why do we need our internet gateway, or why doesn't one is there by default? And route. Okay, we are going to do an illegal thing, and we'll just copy this, paste, and Terraform, apply. maybe we should read instance takes AMI ID, instance type, subnet ID, UPC, public ID, key name, security group, and subnet ID. These are the two things it takes, and subnet ID and security group. Okay. Egress and include, exclude. That is cool. Cool. Let's now we have to add our key. This thing removed our key. This thing removed our key. We were adding our keys. Key name always should key name is going there still. Terraform, apply. Yes, what can go wrong? Terraform working at its best, and Bro's video is like we only completed half of his video. Okay, that is pretty good. We don't see the output. Shit, yes, we don't see the output. We should add back the output. Not much change, just the output. This is it. Admin 1.3.2 3437.2 we will do. Yes. Oh, okay. Now it is working, and we are able to create a EC2 instance and SSH into it. Cool. That would be it. I guess that would actually be it. It is pretty late, and we didn't complete this, but we are able to. And yes, we will. I would have to read what all this means. We do know some things, but internet gateway and different things. Yeah. For now, this would be it. We are able to create a new EC2 instance using Terraform and give it a public key and SSH using that public key. Yep. Cool. And that will be it for Terraform for now. And thank you for being here. Bye.